mostly a review and I'm kind of treating it as such. I'm going to touch on everything. If there's something that you need more detail over or more examples of, I'm happy to do it. But this is something that you've seen. We know complex numbers, you're used to seeing that I with things, imaginary numbers. So the definition of I squared is equal to -1, which then means hello. All right, so that means I is the square root of negative. So when we see complex numbers, we're used to seeing things of the form a plus bi. That's what's called the standard form. So it's always the real plus the imaginary. A is your real part because it's just a real number without an I. B is considered the imaginary part because it's the coefficient of the I. When we have these complex numbers, they can be classified. So complex is really every number you see. It's not just the ones with i's in it. It's anything of the form a plus bi, but either of those can be 0. So it's like 2 plus 3i. Or 2, because your imaginary part is 0. Or 3i, because the real part is 0. All of those are actually considered to be complex numbers. Within those complex numbers, we have 3 different types. The real ones are the ones that don't have an imaginary part. So things like 2, -3/4, pi. Those would all be real numbers. They don't have an I with them. They are a complex number, but they are also real. Pure imaginary are complex numbers that don't have a real part. So something like 4i, -1/2i. Those are pure imaginary. And then non-real complex has both terms, the a plus bi. So that's your 2 minus 5i. -6 plus I. It has both a real plus or minus an imaginary. All right, so let's look at an example. And I just want to classify each of these using the words real, complex, pure imaginary, non-real complex. All that apply. So I told you all of these numbers are automatically what? They're all complex. So I could say that on every one of them. All right, and then it's either real, pure imaginary, or non-real complex from there. So what would 13i be? Pure imaginary. It doesn't have a real number added to it. What about 5 plus I? It has both parts. And what about pi? Real, because it doesn't have an imaginary part. All right. Any questions about classified numbers, that terminology? What we really want to focus on today is what happens when we have an I in our problems, and where does the I come from? I is the square root of -1. So if you have a problem with a square root and a negative underneath, essentially what that means is you can separate it, break apart the 5 and the -1, and the square root of -1 is I. I think most of the time you guys wrote it as I radical 5. Technically both are correct, but this notation is a little more obvious to see that your I is outside the radical, so that's usually why you wrote them that way. So if there's a negative under your radical, you take an I out. Alright, so I'm going to put a couple up here. Can you guys tell me, what is the square root of -1? I. What is the square root of -16? Square root of 16 is 4, and the negative makes it I. Right. Square root of -8. Yes. So you have to break down 8 into 4 times 2. The square root of 4 is 2. We still have the square root of 2. And because it had a negative, you take out that I as well. So 2I radical 2. You guys okay with how we broke that down? When you are working with imaginary numbers, it is important that you take out the i's before you multiply these together. If I give you the square root of -4 times the square root of -9, if you just multiply, -4 times -9 is 36, and that gives you the square root of 36 is 6, right? But that's actually the wrong answer. If you broke these down, what is the square root of -4? 2i. What is the square root of -9? If you multiply those, what do you get? And at the beginning I told you I squared is, and 6 times -1 is -6. So this is wrong. Take out the I before you multiply. Otherwise your signs will be off at the end. Okay, I want you guys to try this. So the square root of -7 is I radical 7 times I radical 7. If you multiply those, you get I squared times the square root of 49, or you might have already just wrote 7. So I squared is -1, square root of 49 is 7, and we get -7. What'd you guys do first on B? Okay, you broke down that radical first. That'll work. So there's really a couple options. You could have, I saw most people at least took out the I. What happens to the I's on top and bottom? Cancel. Now, some people then broke down the square root of 20, but here's a shortcut. If both of them are under a radical, you can actually divide them first. It saves you a lot of time. What is 20 divided by 2? So that actually just turns into a square root of 10. So you can reduce the radical 20 and break it into 4 and 5. So you get 2 radical 5 over the square root of 2. But what's wrong with that? You remember? We can't simplify them. You also, proper notation doesn't let you leave a radical on the denominator, so you have to then multiply the square root of 2 on top and bottom. So you get 2 radical 10 over 2, and then you get your square root of 10. So you can get there both ways, but faster to recognize that they're both under the radical, you can divide first. All right, do you remember how to add, subtract, and multiply with imaginary numbers? Adding and subtracting, it's just like any other adding and subtracting, you combine like terms. One thing, answers do need to be written in standard form. So A plus BI. So we want real plus imaginary. So 3 plus -2 is 1. 5i plus 3i is 8i. How do we subtract? And then combine like terms. So 6 and negative 3 is positive 3. 4i minus 6i. What do you think we do for multiplying? FOIL. So we get 10 plus 35i plus 6i plus 21i squared. Like terms, 35 and 6 is 41i. What do we do about the 21i squared? This is like 21 times negative 1, so we get negative 21. Are we okay with that? So then, like terms.
Freshmen and sophomores are dismissed to the cafeteria at this time. You do not need to bring anything with you, no Chromebooks or notebooks or anything like that. Freshmen and sophomores are dismissed to the cafeteria at this time.
Combine like terms, make sure you put the real first. So real plus imaginary, so negative 11 plus 41i. All right, any problems adding, subtracting, multiplying with these? Let's talk about powers of I. I know this. Yeah. Okay. I don't really want to write 15 i's out and multiply it together. So we have to be able to simplify this in some way. The key thing is, every time you get 2 i's, what does it turn into? Negative 1. I squared is negative 1. So let's figure out how many groups of 2 do we have. So we're going to rewrite this. 15. How many times does 2 go in there evenly? 7 times. Okay. 2 times 7 is 14. That accounts for 14 of my i's. We still have 1 left. But I squared is negative 1. So I have negative 1 to the 7th times I. If you have 7 negatives, is your answer positive or negative? Negative. So this is just negative 1 times I or negative I. If I said I to the 22nd, how many groups of 2 can that make? 11. Any leftovers? No. What's I squared? What happens if you have negative 1 11 times? 1. Alright, I want you guys to try a couple. Let's do I to the 36th power. We can break them into 18 groups of 2. So that's I squared 18 times. Negative 1 to an even power is positive 1. If you have I to the 5th, how many groups of 2? 2 with 1 left over. So we get 1 squared times I. So 1 times I is I. When you do these problems, the only answers you can get are the 4 answers we got up here. I, negative I, 1, and negative 1. Those are the only things you'll ever get. Any questions on that? Okay. 2 more things I want to talk about with our I's, and then we're done. Let's actually do B first. Standard form is A plus BI. You cannot have I on the denominator. So how would I get I off this denominator? Multiply by I. Are you boys with me over there? Look, you know, there's like a whole empty row behind you guys. You could spread out and then not be so tempted to talk. Or there's even an empty seat over here. All right, what would I do now? Yep, I squared is negative 1, and we get negative 3i. So always get your I off the denominator. On A, if all I did was multiply by I, my denominator becomes 5i minus I squared. Did that get rid of the I? No. So what am I going to multiply by this time? The conjugate, which is the same thing but opposite signs. I know you guys were all close, couldn't think of the word. So 5 plus I. And how do we multiply these? FOIL. So we get 15 plus 3i and plus 10i, so plus 13i. Are you guys okay if I go ahead and combine those like terms as I'm foiling? Okay. On the bottom, when we multiply, we get 25. Plus 5i and minus 5i cancel, minus I squared. Okay, so remember, what would 2i squared turn into? 25 minus I squared would turn into plus 1. Combine like terms, you get 13 plus 13i over 26. What else do I need to do? Divide them. Because I said standard form, first of all, this fraction can be reduced, but second of all, standard form wants us to go ahead and break it apart. So think of it as 13 over 26 plus 13 over 26i. Each term gets, on the numerator, gets divided. So we get 1/2 plus 1/2 I. So if it tells you standard form, break apart that fraction. Is that one okay? Last example I want to do is just some situations where you will see these imaginary numbers. This is actually an expression that you might see when you do the quadratic formula later on. You remember doing the quadratic formula? We sometimes encounter things like that. So I want to make sure we know how to reduce this. Where would you start? So we have to break apart a fraction, we have to reduce our radical. You can start either of those places. If I start with my radical, so we know we have to take out an I because of the negative. What multiplies to 1/28 then? It's a perfect square. Bless you. 64 and 2. Square root of 64 is 8, so that's 8i radical 2. Then we divide each one by 4, so negative 8 divided by 4 is negative 2. 8I radical 2 divided by 4 be 2I radical 2. Am I going too fast with this stuff, or is it coming back? Doing okay? Alright, you guys do B. If we get that, then I am done. Alright, so we know we need an I. You need a perfect square that goes into 200, so you could do 102. Square root of 100 is 10, so 10I radical 2. Now you have to divide each term by 5, so 10 divided by 5 is 2. 10I radical 2 divided by 5, when you do that, you just divide the 10 and the 5, so 2I radical 2. Alright. So, we have about 15 minutes right now. I want you guys to work on your homework so you can ask me questions. It's not as many problems as it looks like, it's like 12. So.